All right. Um, Couple things I want to do today, and there are still people kind of getting on and doing the thing on campus that needs to be done every day. So just assume that you're going to have to do that. Um, there'll be one up every day. That's how I'm going to take attendance, and it's also worth points. And right now, it's worth points on the exam, so it's worth a pretty good chunk of your grade right now. Um, Couple things I want to do today. I want to go over just the guidelines of this remote learning for the next couple weeks. And then I want to start content. Okay. Um, so this on your screen, this was sent to you in your email, and if you haven't read it, you need to. Okay. This is also sent to your parents, so they're on the same page that we are. Um, and I just want to run through kind of the important parts. I'm not going to read this word for word. You guys can do that kind of on your own time. But I do want to highlight a couple of things. First, um, every day, no matter what you log into on campus at the beginning of class, you respond to the prompt, um, and then you come here. Okay, just assume that we're going to be doing something here, and if we don't, I will make sure you know that ahead of time. Um, this will start about 5 minutes after the time class actually starts. It might be before, but it'll definitely be within about 5 minutes. Um, for now, we're going to be using comments for questions for this like general part. Questions should be specific questions only. All right. So I get that you guys are saying hi to each other right now. That's great. You can do that at the beginning. From here on out, though, like when I'm actually lecturing, I want this to be specific questions only. That helps me kind of go through the chat and actually see what needs to be covered more, or what people understand. Um, I don't want, no, I don't get this. That's not helpful. It's not specific. Um, and I'm not going to answer questions unless I know your actual name, right? So if your name is not your first and last name in chat, that's fine. Uh, but when you ask, I need to know who you actually are. Otherwise, I'm not going to answer it. All right. Um, I will try to make these streams under 45 minutes. Today might be just a little bit over because I have to go through this stuff first. Um, but ideally, these are under 45 minutes. Uh, After that, I will be available in teams, which we're going to all do together today, where I can help people a little bit more individually, uh, and in kind of a group setting. All right. Um, there will be homework, and I will grade it. Some will be IXL, some will be worksheets. IXL is going to work the same way. You just do it, and I get your grades from that. If it is a worksheet, I'm going to have it in Teams, and you will complete it in your notebook in Teams. That way it's all in one place, and I know exactly where to look. If that doesn't work, I have plans. But for right now, it'll be on Teams. We don't have that today, but that's what we're going to go and do later on. You will be graded every time you are here. So if you don't comment, you're not going to get points, and you're going to be marked absent. We are keeping track of attendance. And I realize you guys have heard a lot of this said before in all of your other classes. That's fine. I just want to make sure you understand it and hear it from me. Um, you are required to be present. If you have a legitimate reason, you need to tell me. I will take attendance toward the end of class. So if you're having a couple of minutes to actually get in, uh, and get started or respond to the prompt, um, that's okay. I'm going to be giving points and taking attendance toward the end of class. Uh, I also don't want you just to reply and walk away. I want you to stay here for this lecture. All right. So normally I won't actually give out homework at the beginning. I will give it during class. Besides that, you need to be in a place that is okay for you to learn. Um, if you're in bed or something, that's probably not good. You need to be at a table or a desk just so you can take notes and listen and actually still be engaged in a class. All right. I'm okay with you having music on right now, so long as it's not turned all the way up and you're just reading. If you're just watching me write or reading what I wrote, that's not good enough. Okay. Um, you need to be able to listen to what I'm saying because that is also important. All right. Um, like right now, I have music on in the background, but it's really, really soft, just so I can have something to keep me focused. All right. Besides that, tests will be different and retakes will be different. So I haven't graded your test just yet. I've been kind of working on this stuff for the last couple of days. Your test will be in shortly. Uh, how that's going to work with retakes, I have an idea. And how tests are going to work, I have an idea. I'm not totally sold on either of them yet. But what I'm thinking is that you actually just video yourself explaining a problem in real time, and I will grade that. And not just a problem, but a set of problems. And that would be your test. Okay. Um, if you have questions one on one, if you have like a one on one question you want to ask me, I will be in Teams after this, and then you can ask then. Uh, if for whatever reason you're the only one in the chat, I'm gonna ask you to be in an open area. Um, that's for both you and me, and that's a rule that was put on me by administration. That's a rule that was put on everyone by administration. So if you are going to be talking to me one on one, it needs to be in a place that anyone could be. All right. Um, this is not an extended spring break. Okay. I know it may feel like it because you're at home, you're in a different setting. That's fine, but I'm still expecting effort. This is still class. Your parents are still paying for this. Um, I'm expecting the same effort that you would put forth in a normal class, if not even just a little bit more, because you're in a different setting, and it's just different. Okay. Communication here is key. If you don't understand something, you need to tell me like immediately so we can get you caught back up. All right. Falling behind here is a little bit more dangerous than falling behind at school. I can usually see where kids are struggling at school, but because I'm not there physically with you, it's a little bit harder to do that. Different classes might look a little bit different, but for the most part, that's kind of our structure. All right. So you log into On Campus, you respond to the prompt, you come here, you watch the lecture, you take notes, and then you go to Teams for questions and or for just listening to me explaining problems to people. Okay. So that's the structure. All right. On Campus, YouTube, and then Teams. Those are the three things that we'll use pretty much every day. Okay. Um, on a slightly different note, with this stream, when I say something, it usually takes about 5 to 10 seconds for you to actually hear it. Okay. So I'm going to move just a little bit slower to give you guys times to actually answer questions. Okay. So if it seems like I'm moving slow, that's probably okay because I am. Now, that's this. You have a copy of this in your email, so do your parents. But are there any questions over any of this before we move on to actual content? Okay, so if homework does come on a worksheet, um, I will post it to Teams and on campus. Like there should be a printout on both places. Um, in Teams, all you have to do is do the worksheet in your notebook, in like your OneNote notebook, and then I'll just be able to see it. So you won't actually have to submit anything. You'll just have to complete it by the time I grade it. Um, if I give a worksheet and for whatever reason the entire class hates using Teams, which in my opinion is probably better for this than anything, at least Teams is. Um, I will give you the worksheet. You'll write it on paper, and in some way submit it to On Campus. So you can either do that on a PDF by writing notes on it, or you can take a picture of it and send that picture to On Campus, and then that'll be your submission. Okay. Why does this go to our exam grade? This goes to our exam grade because, and it won't always go to your exam grade. I'm going to make that pretty clear. I'm going to make this worth your while, though, to actually show up to class and respond and be present. If I don't, and people don't start to show up, then it becomes a problem. So we were told by our administration to actually make this worth a significant amount of points. 1 or 2 points on your exam, or 1 or 2 points in a project or in a quiz, that's significant over the amount of time that we're going to have to do this. All right. So we're doing this for at least 2 weeks, and I have a feeling it's going to be a little bit more. So picture 4 to 5 to 6 classes, 2 points each in your exam. That could add up to about 12 points. And if the actual exam is worth 70, like that's a big chunk of your grade right there. All right. That's why. All right. Any other questions, and then we'll move on. I'll give this another like 20 or 30 seconds, and then we'll go to actual content. All right. Now, you need a notebook in front of you. You need to be writing notes. All right. So we're going to actually cover new content. So this is stuff that is different. Again, guys, this chat isn't for you right now. This is for questions and questions only. If you don't have a notebook, you need to figure it out, and you need to get one, or you need paper to write stuff on. That's it. So you need to do that on your own right now. Okay. Now, this new stuff, we've done a lot with triangles over the last, really, this semester. Okay. So we've done a lot with triangles since like December, maybe even earlier in November. All right. We've classified them by sides. They can be equilateral, isosceles, and scalene. We can classify them by angles. They can be right triangles. They can be obtuse triangles. They can be acute, and they can be equiangular. All right. We've also proved triangles congruent by SSS, side, side, side. So if 3 sides of one triangle are congruent to 3 sides of another, then we know that those 2 triangles are congruent. We've proved it by SAS. So if 2 sides and the included angle are congruent to 2 sides and the included angle of another, then those 2 triangles are congruent. Similarly, we've done ASA and angle, angle, side. So we should know how to prove congruence of triangles using those 4 methods. All right, you've been tested on that. A lot of people have taken retakes on it. These are things we've done. Okay, we've also proved similarity, which was just last chapter. That was the test that we just had. And we proved similarity by SSS. So if 3 sides of one triangle are all proportional to 3 sides of another, then those 2 triangles are similar, rather. If 2 sides are proportional to 2 sides of another triangle and the included angle is congruent, then those 2 triangles are similar. Okay. We've also proved that if 2 angles of one triangle are congruent to 2 angles of another, then those 2 triangles are similar at least. All right. So that's all the triangle stuff we've done. Within that, we've also dealt with the Pythagorean theorem. Okay. So in a Pythagorean theorem, in a right triangle, if we have the hypotenuse of length c And we need to know that the hypotenuse is always the longest side and always opposite the right angle. C squared, that length squared, is equal to the length A squared plus the length B squared. And we did a little bit of that very early last chapter, and that was kind of a hint as to what we were doing next. Okay. Also with that, we've dealt with proportions and we dealt with radicals. Okay. So proportions, I'm hoping that we're all really comfortable with. I want to do a really, really simple radical right now. So say we have the square root of 12. Okay. We need to be able to simplify that by pulling out perfect square factors. All right. So our one rule with radicals is that we can write them as factors of our square root of different factors. Okay. So we can rewrite the square root of 12 as the square root of 4 times the square root of 3. Right? Because 4 times 3 is 12, and then they both have a square root on top of each other. Now, we can simplify the square root of 4 as just 2, right? The square root of 4 is 2. The square root of 3 remains there, because we can't simplify that any further. So the square root of the square root of 12 simplified is 2 square root of 3. Okay, so we've just done that kind of stuff as well as proportions. Are there any questions about anything on the screen so far? Okay, now again, if we listen to what I had said earlier, we always start and on campus. We always go here to the actual lecture, and then we go to Teams. So yes, we're going to go to Teams after this. And yes, these are all available after we're done. Okay, so my period 3 class is already even up. Okay, so I've already lectured this before. So if you ever want to see that as well, it'll be up on this channel. Right? Okay. Now, in terms of new content, we want to deal with right triangle trig. And actually, before we get to here, in this chapter, we're going to be dealing with right triangles and the Pythagorean theorem quite a bit. Okay, so we need to be very comfortable with what a right triangle is and the Pythagorean theorem. And along with those two things, we also see the distance formula a lot. All right, so these 3 things right here are going to be really the basis of what we're going to be doing next. Okay, and what that is right triangle trig. Okay, so up here I have a right triangle, and we need to be able to know just a couple of things about this before we even get into new stuff. All right, so in a right triangle, the most simple is you need to be able to actually find the right angle, which should be easy. It's always going to be marked. And we need to be able to find the hypotenuse. Okay, so the hypotenuse is always going to be the longest side, and also the side opposite the right angle. So if we take a line going from the right angle, if we draw a line within this angle, we'll always find the hypotenuse. Okay. And it's also the longest side. So that's step 1, just being able to find the hypotenuse. That is a very, very important thing in what we're doing next. we're also going to need an angle theta. All right, so a different angle. The angle theta is basically like x, but we're dealing with angles, right? And from this angle theta, we need to be able to know two sides. We need to be able to know the opposite side, which again, if we draw an angle within these two white lines, we'll always find the opposite side. And then the side attached to the angle theta that is not the hypotenuse is the adjacent side. Okay, so we need to be able to locate the hypotenuse, the opposite, and the adjacent sides, as well as know about what theta actually is. It's just an angle. Okay, so are there any questions so far about what I have up on the screen? Okay, now, this angle, really all three of these angles, but this angle in particular, this angle theta, has a relationship with each of these three sides. So it has a relationship with the hypotenuse, the opposite side, and the adjacent side. Okay, and there are three different functions that we need to know. So we need to know the sine of theta, the theta is just an angle. It's almost like x. So if you wanted to replace theta with x, you're more than welcome to do that. But we're going to be talking about it with theta. Okay, so there are three functions. There are three right triangle trig functions. Okay, so there's the sine of theta. There's the cosine of theta. And then there's the tangent of theta. All right, and each of these are just ratios of different sides. So the sine of theta is always going to be the opposite side length over the hypotenuse. The cosine of theta will always be the adjacent side over the hypotenuse. Yes, sine with an E and sine without is kind of the same thing. Usually people refer to it as just sine, S-I-N. But in terms of a function, you'll always see it S-I-N. All right, and then the tangent of theta is always going to be the opposite side over the adjacent side. Okay, so these three functions, the sine, cosine, and tangent, those are just ratios of the opposite, adjacent, and hypotenuse. That's all it is, okay? And it's always going to be a fraction. It's always going to have numbers in it for now, or at least this year probably. Okay, one way people remember this is Sohcahtoa. So sine is always going to be opposite over hypotenuse. Cosine is always going to be adjacent over hypotenuse. And tangent is always going to be opposite over adjacent. Okay. So we need to know pretty much everything on screen. We need to be able to locate the opposite and adjacent sides, as well as the hypotenuse. We need to know what the sine, cosine, and functions actually stand for. And then this Sohcahtoa should help you do that. Okay. Are there questions about anything on screen? So how do you determine where opposite, hypotenuse, and adjacent go in the triangle? It's all dependent on this angle right here. Okay, so the angle theta, the unknown angle that we're talking about, this angle, circled in red, that determines where the opposite side and adjacent side are. We always know where the hypotenuse is. The hypotenuse is always opposite the right angle. Okay, the adjacent side is always the other side attached to the theta. And the opposite side is always the side all the way on the other side of the angle theta. Okay, so if we were to redraw another triangle, you guys are not finding theta yet. Theta will always be given to you. Okay, theta's placement will always be given to you. We will find theta a little bit later, but theta's placement is always given to you. All right, so say, for example, this angle right here is theta. And I want you to just tell me where hypotenuse, adjacent, and hypotenuse are. So opposite, hypotenuse, and adjacent are. The hypotenuse should be fairly easy, all right? It's always the longest side, and it's always opposite the right angle. So if we take a line directly from the right angle and draw to the other side of the triangle, that's our hypotenuse. The side, yes, theta's placement is always given to you. Okay, so this green angle theta is always set for you, and this blue angle theta is always set for you. Okay, so we should know how to find hypotenuse. The adjacent side is always the other side attached to theta. That's not the hypotenuse. All right, so the other side attached to theta is this side right here. And then the opposite side, if we draw an angle from theta, or so if we draw a line from theta to the other side of the triangle, that gives us the opposite side. So I'll give you a couple of seconds to catch up writing and just kind of look at it for a second. And if anyone has any questions over the next like 20 seconds, that's fine. You can ask that too. You will not be trying to figure out what theta is. And I'll show you an example here in a second. But you're basically just trying to find the ratio. We will find theta a little bit later on, but we're not there yet. Very basically, Seamus, yes. The question will say find the sine of theta, find the sine of x, find the sine of b, whatever. And you'll have to give it the ratio. Okay, so for example, and I have a bunch of examples in on campus. So if you go to topics and then go to right triangle trig, there's two downloads. There's right triangle trig practice and right triangle trig practice harder. Okay. There's 20 for each. All the answers are on there. So that's a good set to practice. We'll do a couple of examples and then we'll move on and go to teams and ask if you have any questions. All right. And then I'll give you the homework as well. All right. So, and I'm going to be using examples from this. So if you have any questions about that, you can always go back to those questions and try and do them yourself without help. All right. So for example, we'll do number 4 on the first handout in that topic section. Okay, and it says find the sine of C given this triangle. All right, and it gives you that the lengths are 14, 48, and 50. All right, so we know from up here that sine is opposite over hypotenuse. All right, so we need to locate the opposite side and the hypotenuse side. Again, the best place to start is always the hypotenuse, right? That hypotenuse is always the longest side, which in this case is made pretty explicit because it's just the biggest number, right? So our hypotenuse is 50 in this case, okay? If for whatever reason you're not entirely sure, you can always go to the side opposite the right angle. All right, so we found opposite. Now we need to find we found hypotenuse. Now we need to find the opposite side. Okay, and this question is asking about the angle C. So you want to go to the angle C, and we need to draw a line to the opposite side of the triangle of C. So our opposite side is 14. And then we can simplify that just a little bit. Okay, so 2 is in both 14 and 50. 2 is a common factor. So we can reduce this to 7 over 25. So theta in this case is the angle C. All right, so theta, again, it's just a variable. It can be a lot of different things. So in some cases, I ask you to find A or B or C or R or M or N. In this case, we're just talking about the angle C, right? So say for a second, instead of sine of C, and this is not necessarily on your handout, but we're going to use the same triangle. Instead of sine of C, I ask you to find the cosine of A. So keep in mind that the cosine is always the adjacent side over the hypotenuse. The angle that we're talking about is always the thing inside parentheses, or the thing just to the right of the sine or cosine or tangent. In this case, it's A, right? So we need to find A. It's right there. That's our angle. So this angle right here, that's our angle theta. Again, we know the hypotenuse. That's 50. Now, the adjacent side to cosine of the adjacent side to the angle A is the side attached to angle A that's not the hypotenuse, which in this case is 14. And again, we can reduce that to 7 over 25. The question is this. Find sine of C. Sine of C is the ratio 7 over 25, which was done right here. Okay. This second part, that's just me asking, just to do another example. Yes, the answer to this question is just 7 over 25. We'll do one more of these and then move on to a little bit harder one. Are there any questions over this one before I scroll down a little bit? Okay. In that same handout, we'll do number 9. So number 9 says to find the tangent of x given this diagram. Okay. Sine is not always a letter. Tangent is not. Tangent and sine and cosine, they're all functions that give you a ratio of sides. All right, so number 9 says to find the tangent of x. Okay, the first thing I like to do is just explicitly state what tangent actually is. Tangent is always opposite over opposite over adjacent. Right, Sohcahtoa. All right, and we're dealing with the angle x, which is this angle right here. So the opposite side to x, if we were to draw a line from x to the opposite side of the triangle, we know that the opposite side is 16. Our adjacent side is the side attached to that angle x that is not the hypotenuse. All right, so it looks like 20 is our hypotenuse, which means 12 is our adjacent side. It's the side attached to the angle x. And then we reduce that a little bit to get 4/3, and then 4/3 is our answer. So the tangent of x is 4/3. Are there questions about this example? Yes, in this case, I definitely want fractions. So fractions only, yes, fractions only. Can it be simplified into a whole number? If it can be simplified into a whole number, you can do that. Just as long as it's fully reduced. Again, we are not solving for theta. All we're doing is solving for the tangent of x, or the tangent of theta. Okay, so all we're doing is getting a ratio of side lengths. Okay, x in this case, or theta in any other case, is just pinpointing an angle that we're talking about. So we're talking about this angle x, and we want the ratio, the tangent ratio. We want that tangent ratio, which is opposite over adjacent. Okay, so you take the opposite over the adjacent and then simplify, and that's your answer. We're not solving for the angle. We don't do anything with angles just yet. We will, but we need to do these 3 trig functions first. So in other words, right now I'm not going to ask you what is the angle x. We don't know how to do that just yet. But I am looking for the tangent ratio for the angle x. So I'm looking for the tangent of x. Okay, I want to do one more example that's just slightly harder. This is number 12 on the second worksheet in that topic section. All right, and number 12 is asking to find the cosine of theta for the given diagram. Okay, so given this diagram and that placement of theta, we need to be able to get the cosine of theta. And we know that cosine is adjacent over hypotenuse. Okay, so we can find the hypotenuse side pretty easily. It is the side opposite the right angle, which is 12 root 5. And then the adjacent side is the side attached to the angle theta that is not the hypotenuse. So the side attached to the angle theta that is not the hypotenuse is 24. Now, this is not a final answer just yet. Okay. So this is not a, quote, rational fraction because it has a square root in the denominator. In order to make this an acceptable answer, we have to rationalize it. And what that means is that we have to get the square root out of the denominator somehow. Okay? And we do that by multiplying by some clever form of 1 that somehow cancels out the square root. And I want you to recall that if you have ever have anything that is a repeating square root, so like the square root of a times the square root of a, that is always just the thing underneath the square root. So in this case, in order to cancel out that square root of 5 in the denominator, we have to multiply by the square root of 5 over the square root of 5, which we can do because the square root of 5 over the square root of 5 is just 1. So then we can start to simplify this. So if we multiply these two fractions together, we get 24 square root of 5 over 12, and then this square root of 5 times this square root of 5 come together to just be 5. So it's 12 times 5 in the denominator. So then you get 24 root 5 over 60. And then we reduce that like any other fraction. So 2 goes into 24 and 60. So if we take 2 out of the denominator and numerator, we can further reduce it. And then 2 root 5 over 5 is our answer. Okay, and then that would be something that you could put on a standardized test or IXL. Okay, so take a second. Are there any questions over this example? Okay. Now, your homework, and this covers all of this, is R1. Okay, and I am pretty sure everything we just did covers all of it. If it doesn't, um, it doesn't cover the last 5 points, um, but we should still be able to do that, because really the only harder problem would be to give you to use the Pythagorean theorem in order to find a third side that you need for a certain ratio. Okay, if it gets to that point, that's okay. Try your best, and if I need to extend this deadline, I can. But for now, I think you should be able to finish it. Okay, so right now this is due on Friday. All right. Okay. So first, you can always go back and rewatch this or different parts of it. This is here for you. What I would like to do now is to move everyone to Teams. So if everyone can log on to Teams and go to our section in Teams. All right, I'm going to start a meeting. Please join that meeting and just see what it looks like. And if you have any questions while doing the IXL, I'll be around for a couple minutes. If not, that's fine. You can work alone. You can work on there. It's really up to you. Okay. So I'm going to end the stream in the next 30 seconds. Before I do that, if there are any questions I can answer right now, go ahead and ask them. So, and then about 30 seconds, I'll move to Teams and we can go from there. Yeah, so the IXL is due on Friday by next class. Okay, so I'm gonna end this. I'm gonna go to Teams. I'll start a meeting. Just join and just see what it's like. All right. So I will see you in 30 seconds.